Isn't it amazing what we can do with all this tech?
Yes, it is amazing.
It's crazy, really. You know, we're literally on different sides of the world. Facebook's saying it can't connect. Oh, what's going on there? This is the one that I'm not so clued up on.
Yeah, unfortunately not me either, Paul.
Yeah, so I created an event for it. Let's just see. Change it. Okay, just going to do that again, and I'm just going to do Periscope now as well. I know it's a little bit early, but because I haven't done that before either. Hello, Slooh. Is anybody who's joining us at the moment? Hey, I had a great conversation earlier with somebody via email, and we were talking about. I've always called Slooh members Sloohers, but we reckon Sluvians.
Oh, yes.
Yeah. Do you reckon?
Yeah.
Sluvians is pretty cool, isn't it? Right, so I can't do Facebook there, Todd. So I'm not going to get that wound up about that. We are on Twitter. We are on YouTube. So I will just try one last setting.
And of course, tonight will be Jovian Sluvians.
Jovian Sluvians. Oh,
tonight will be Jovial Jovian Sluvians.
Oh no! You see, that's easy for you to say at that time of day in New Zealand, but not here. Not here. No, can't get the
then,
Facebook.
Okay, how about this will be nocturnal Jovian Sluvians?
Now you're just pushing it, Mike.
That's what I do.
Hey, Andrew's in the house. Hello, Andrew. Right, so Facebook just stopped. So Facebook is stopped. Okay, so we haven't got Facebook, but we have got YouTube, we have got Twitter. So that's all good. Just get my own act into gear because we're a couple of minutes away. We're kind of live on all these channels, so people watching us now from around the world. I hope lots of Sluvians join us in the actual star party tonight.
It looks like mine's showing 25 participants awaiting us.
Okay, that sounds good. Hey, Andrew, how are you doing? How'd you get on with Canary 4? Have you knocked it into shape?
It's close. Might have to continue tuning, but without the config mistakes.
Well, it's been really hot there today. You know, so the telescopes really. I've been there during the summer, this kind of time of year, and the telescopes, frankly, don't cool down. They never reach ambient temperature at some points of the year like this up there. You know, so we're fighting it there, but is Chile still looking good? I have not checked. The last time I checked the all-sky, it was looking pretty darn good. So we'll take a little quick look at that before we start the show. Oh, look at this. Oh, it's like magic, isn't it? Our first really decent, clear night. Oh, did I say that? No, I'm going to take that back. Yeah, the weather looks okay down at Chile. Yeah, we'll be fine. Nothing's going to come over. So that's looking pretty good, isn't it? So don't actually see.
Oh, nice.
Jupiter coming up over the hill yet.
I was out last night. I saw it coming up, and it was just like a spotlight. You know.
Yeah, exactly. You know, and but we've got this little white thing that I'm pointing out on here. That's the Andes Mountain, and that's the local snowfall, which actually kept us closed for quite a bit. But anyway, we will go live in about a minute's time. I put some polls together for this. Nice. Show, and I've forgotten what they were, so I'm just going to have a look. Oh, okay.
First, we are live on Slooh, Paul.
We are live. Okay, I'll get my act into gear. So welcome, Sluvians. You may have heard us talking a little bit earlier. I know there's some people out there on internet land as well, looking in tonight. welcome everybody. Opposition of Jupiter 2020. Anybody who knows Paul Cox from the last 20 years or so knows that Jupiter is my favorite ever celestial object in the night sky. So tonight it's better than my birthday. So anyway, we are going to have a little poll a little bit later on. What is your favorite solar system object? I think there's another poll in there as well. Hey, listen, who have we got joining the live star party? This is all Slooh members in here tonight. In fact, if I move this, because I hadn't realized this, you know, folks, when, oh, now I've lost you all together. When no, I can't get you over to the other screen. That's the problem. Have you lost my screen share now?
Nope, you're there.
Still there. I was looking at the recording of a Zoom webinar, and it only actually has the speaker and the screen share. So if people are out there in internet land on YouTube or on Facebook watching at the moment, to see all of the other Slooh members, you've got to be a Slooh member and come over and join us. But who have we got tonight? So just so that people know, people in the webinar, so I know who else is with us tonight. We've got Todd. Todd is VP of Engineering. Have I got it right, Todd?
Thanks, Paul, and welcome everyone.
Yeah, I got it right for a change. We got Dr. Mike Shaw here tonight as well, joining us from New Zealand. Mike, which island are you on? I've never asked.
Well, actually, I wish I were on New Zealand, but I'm in sultry Minnesota. And,
Minnesota.
Middle of
no, I'm thinking Cameron. I'm sorry. Minnesota.
Right.
Okay, it's because that's why your backdrop is different to the one I remember the last time I spoke to you, because I was talking to Cameron.
I've cleverly positioned my 2 books on astrophotography here. Yeah, I don't know if
that's very good. Have you noticed the trend in people arranging, you know, books specifically behind them?
You know, there's I don't want to get too off topic immediately, but there's a great Twitter account called Room Rater. And it rates people's rooms, and it's quite, you know, pick up some good pointers.
Okay, well, you know, I'm an absolute Philistine. No books. It's just black screen behind me.
That's referred to as a hostage room, Paul, to be perfectly honest.
Is it? Is it? Well, I am hostage to Slooh Quest, and we are going to have a look at the latest Slooh Quest, which launched tonight, which is all about this event. So Slooh members, actually, before I go around the houses and see where everybody's coming from tonight, you need to hop over to the telescope pages tonight. Let's see what Andrew's done with Canary 4. Andrew Dumbleton, Slooh's ops manager, is here as well with us tonight. Andrew will be joining us throughout, keeping the telescopes running. Okay, this is not too bad. So bear in mind, at the moment, Jupiter is really, really low still in the sky. In fact, it never really gets that high from the Canary Islands at all. But what we can see here is I can just see a smudge of a moon here. I can see a smudge of a moon here. I can see a dirty spot on there. And there was a post actually being discussed in one of the Slooh clubs. And this was an image from last year. And a member was asking, what is this? Haven't seen this on my Jupiter images before. Is it a fly on the lens? But actually, it was the shadow of one of the moons transiting the planet. But anyway, so listen, before I digress, you have got to be snapping for the new quest lots and lots of images. So I just snapped that image there. There it is. That's stored safely in my pictures. Let's take a look at the color in Canary 2. Let's have a quick look over here. How's this looking tonight? So these are the live views. If you are looking in from interweb land, then these are the live views. Oh, that's a bit mucky, isn't it? Seeing conditions are not great. Seeing conditions is when the atmosphere is all rocky and shaky and stuff like that, and the planet's low. Might be a bit better at chilly a little bit later, which is probably online now. But there we can see some color of the great red spot. But you've got to be snapping these images. Oh, I've just seen that Russ Glenn, director of education at Slooh, has joined. That's pretty cool, Russ. Unfortunately, other people probably can't see. If you talk, actually, you'll probably come up live on the screen so other people can see what you're doing.
So that everyone can see that I'm in transit.
Okay, so Russ is doing his best cybernaut impersonation. Russ, we can't really hear what you're saying. You're doing a bit of a cybernaut for us. But we gather from the images, the shaky images and the cybernaut thing, that you are in transit to somewhere. So have a safe journey. You're going to be joining us a little bit later, I think. Tell us whenever you get a good signal, all right? And we'll get you on, because we want to hear some of the latest, because we know we've got loads more schools joining us at Slooh for your online space camp over the summer, which is quite cool. But anyway, we've got a whole stack of other members here as well. Russ, can you, let's see if you're still a cybernaut.
Well, you know, am I coming in now? It's hard to tell.
Yeah, coming in, kind of.
I'm in transit. All right. Well, it's pretty amazing that I'm able to be here at all, since I'm somewhere in Tennessee. So good to be here. I can't wait to talk about all the schools we've got coming in for the summer camps, and looking for the fall as well. So we're excited. There's great things happening here. So good to see you all.
We were just talking actually before the show. Isn't technology wonderful? I'm in the UK. Andrew Dumbleton, he's in the UK as well. Our ops manager, we've got Mike Shaw from the USA. We've got Todd over in the States with Emmanuel, who's running the show for us with Todd in Zoom. And then we got members from just about everywhere. I'm seeing if I recognize a few people there. We've got Carol Botha from South Africa. Midnight there. Carol's been given special permission to come out and play tonight to watch Jupiter. I've got to make sure. Oh, this is getting a bit better, isn't it? Ooh, isn't that pretty? There's Jupiter, that opposition. Hey, Mike, before I carry on waffling on, shall we actually talk a little bit about what opposition is? And while you kind of talk about it, let's meander over, because I've said to everybody, you need to be snapping images of this. So be snapping images, because you are going to need them for the quest. But let's take a quick look at sky conditions just before Mike tells us. So here is Chile. Let's refresh that. That's looking pretty good. Andrew, has Chile risen above, has Jupiter risen above the horizon yet? This is just going to get better and better all night. So let's see if we've got Chile being picked up. Yeah, so Chile normally gives us some pretty good views, and this will give us the best views because Jupiter is really well placed. Oh, that's pretty good. So this is in the Chile telescope, the Chile 1 telescope. We've got what's called a festoon there. Mike will tell us all about festoons later. But anyway, be snapping. You have got to be snapping images from all of these, because while Mike tells us why tonight is special, why I treat it as a bigger birthday treat for me than my actual birthday, then I'm going to show you the new quest that launched tonight. Oh, Andrew Dumbleton's just had a catwalk across his keyboard. Bear in mind that Andrew is controlling the Slooh telescopes, so anything could happen now when a cat walks across a keyboard, which is controlling telescopes. Mike, over to you while I hop over and show members the new quest that we launched today, because I'm really excited about this. It's pretty cool.
Well, it's definitely great to be here, Paul. Thanks so much for Slooh for hosting the event. And, you know, this is just one of those great moments in, astronomy, observational astronomy, when, something happens that is noteworthy. And, there's a number of features about opposition that are, visually noteworthy, but astronomically speaking, it's a pretty simple thing. It's just basically when you can think of it as, Jupiter's going in orbit around the sun, the Earth is going in orbit around the sun. And when Earth, goes right in between Jupiter and the sun, you're 180 degrees, lined up more or less, then we're in opposition. And what that means for us, practically speaking, is Jupiter's huge and bright and big like a spotlight. I was out last night, early this morning, can't even remember. It was last night. And the night before that, trying to shoot the comet Neowise. And it's just no mistaking it here in Minnesota, when Jupiter rises over the horizon, in the sort of in the southeast for us here, it's just unmistakable. It's this enormous red dot that you can just see peeking through the trees at first, and then it slowly comes up into the sky. And you can really get a sense of why, civilizations around the world have for years just been in awe of the, the planets as they wander across the skies. And tonight we have the chance. So basically, it's we're very close to Jupiter. We can, there's not a lot of distance separating us, and it allows us to observe Jupiter and the glorious moons of Jupiter, the Galilean satellites, and some of the other moons, and talking about festoons and all kinds of other interesting things, and the cloud bands. And I mean, Jupiter is a wonderful planet to observe. So this is a great chance. If you have a pair of binoculars, you can observe many of the things we'll be seeing through the telescopes yourself. Encourage you to do that. If you have a telescope, even better. But here we are. We have Slooh telescopes. So,
hey, Mike, you run our Nightscape club, and you do your weekly broadcast about wide field photography. So anybody's got a DSLR camera or similar mirrorless camera, something like that. So explain what we're seeing at the moment, because you were talking about Jupiter being very obvious, rising just after sunset in the east. What are we looking at here?
So this is we're talking about the all sky cam, yes?
Yeah.
Right. So we've got so if you look at the Slooh, the screen that Paul has up right now, this is almost a complete all sky view. So if you were in a planetarium, for example, this would be a beautiful scene to observe. So many things to see here, but since we're talking about Jupiter, let's talk about, if you look sort of in the, there we go. There it is. That's that big, where's it? Okay, that's a time.
That's last night.
That's
so
last
let's
night.
skip through. That's the sunrise this morning, sun at midday. You can see, actually, this is a good shot. We can see lots of haze and dust there, and that's what we're struggling with tonight. So here's sunset then, Mike. So sun is setting in the west. We want to keep an eye, don't we, over on the left, because this is now the sea.
Wait for it. Oh, there's a shadow, bang. Boom. There it came. Did you see it? That was...
Oh, a couple of meteors there. And we caught the ISS. Did everybody see that?
Let's do the. Can you rewind that a little bit? Maybe.
Of course, I can read anything for you.
Oh,
just a reminder to everybody out there: if you're not actually on air asking us a question, if you can stay muted, because we do pick up the background. So here we go. Earth shadow, as Mike said, bang. There's Jupiter, bang. Right, keep an eye. 1 meteor, 2 meters, going straight through.
Yeah.
It went straight through. So this down here is a constellation of Scorpius.
Yep.
And if you keep an eye, we'll rerun it, a couple there. Then just after you see 2 meteors whizzing through here, up at the top right, you'll see the International Space Station whiz across the sky. So let's take it back again.
Yeah.
Oh, we could spend all night doing this, couldn't we? So
there's just so much going on right now. I mean,
keep an eye, Earth shadow, Jupiter rising, Meteor 1, Meteor 2.
Yep.
International Space Station. That's a pretty cool, 30 minutes or something in the all-sky camera. But that looks pretty cloudy to me, Mike. So what's that big cloud thing going through the I was
going to say your dust and haze is my so what we're looking at here is this is really the so we're in July, and during the month of July, the night side of Earth, which is what we're looking at here, is aimed directly at the center of the galactic core. The center of the Milky Way. That's where the giant, massive, supermassive black hole sits that holds everything in orbit. It's the anchor for. There it is. So if you look down at the lower left corner of your screen, you can see that big, bright. The brightest thing on there is Jupiter, and then just off to the left, guess what that is? That's Saturn. How crazy is that? A little bit later on in the night, we're going to see Mars rising, and then we're going to have Venus coming up. Mars was rising with the moon, and then we're going to have Mercury. So actually tonight, my friends, is one of the, and in here is Uranus and Neptune. So tonight and the next several nights, if you're able to get out, especially before dawn, you'll be able to see all of the you'll be able to see, I guess, 4 of the other planets visually, and then Earth, and then you have Uranus, Neptune, and Pluto in there. But anyway, so back to the view here. So the cloudy band that you see arcing from center bottom to upper left, that's the galactic plane of the Milky Way. Yeah. And a lot of people will talk about, hey, I want to go shoot the Milky Way when they're talking about nightscape photography. And of course, it's a bit of because everything you see here is, of course, in the Milky Way. You may be able to pick out a few faint galaxies and whatnot, but of course, as astronomers, we all know everything we're looking at here is in the solar system, which is embedded in the Milky Way. But the key thing here is one of my favorite things to see is, look at this. We have this is a wonderful, this is a beautiful thing for opposition.
Yeah, Carry on talking about the all sky, Mike, and
Oh, sure. Yeah, I want to come back to that.
We'll go back to that. Yeah.
But just a couple of things, though. If you look, if you go back to the constellation Scorpius that Paul was showing out, there's the head and the two claws of the scorpion, and you have Antares right there. It's the heart of the scorpion. Look at that thing.
Yeah.
And then you have Maui's hook, which comes down in a big fish hook. And then if you go sort of off to the left, you can see one of my favorite constellations, which are asterisms, which is the teapot.
Mine too. So handle of the teapot here.
All right.
Triangular teapot lid here, spout here, and the spout looks like it's got steam coming out of it. But you were mentioning the center of the Milky Way, and the spout is a great kind of direction finder for that, isn't it, Mike?
Absolutely. So, just a little bit to the right, just about a little bit off to the right of that bright patch is where the very center of the Milky, and this is why it's so bright and visible, because this is where if you think about it, if you think of a mental image of the Milky Way galaxy, it's a disc-shaped pancake. It's got a bunch of stuff at the center, and that's what we're looking at. So it's kind of, if you tilt your head, imagine that just imagine we're all astronauts. We're on our spaceship Earth, and we're looking at the Milky Way, and there it is. I mean, it's right there. It's incredible that we can see it in that level of detail. So, I mean, go ahead.
Oh, Mike, what I was going to say was we launched another quest last week, which was our summer winter celestial gems quest. Now people
highly
might be
recommend
wondering why we call it summer winter. Well, it's summer in the northern hemisphere where the Canary Islands Observatory is, but it's winter in the southern hemisphere where the Chile Observatory is. But the reason why I'm saying this is all of our southern hemisphere gems, there are 6 of them that we've chosen, are all within this tight little region in and around the constellation of Sagittarius. It is such a rich area of the night sky, and it's cram-packed. It's a Sagittarius arm of our Milky Way, and it's cram-packed to the Trifid Nebula, the Eagle Nebula, the Lagoon Nebula, the Swan Nebula, Wild Duck Cluster. I mean, the riches. I think, Mike, it has to be one of the richest, smallest areas of sky, isn't it?
Yeah, without a doubt. I mean, there's so many Messier, there's so many things to see.
Yeah.
And what's neat about it too is that just coming back to this 3-dimensional scheme, the planets, if you think about, Saturn and Jupiter that we can see there, they're within our solar system. So they're kind of our neighbors. They're really close to the Earth. I mean, those are pretty close to us, but everything else you see is at various distances. And we could go on about that, but it's just something I always like to just appreciate is how we're looking into this 3-dimensional space. And, when you look at an image of this quality, you can see how some of the objects are brighter, some they're going to be closer and bigger and so forth. Some of the objects are dimmer. Some of the objects are so far away, they blend together into bright patches along the galactic plane of the Milky Way. And it's just a beautiful thing to look at. And there's so many things here.
It is. Right. Let's get back. We better hop back to, let's,
want to go through this diagram? This is a great diagram.
Yeah, we'll hop off to that in a sec. I just wanted to, I just want to open this up for a second so that we've got some live telescope views, just in case anybody is not, looking at still a bit muddy Canary 4. I know Andrew's going to be working on this, doing as much as he can to tweak it. But let's hop over to Canary 2. Now, these are all the telescopes. If you are new to Slooh, these are all the telescopes that we've got online. So we've got Chile 1, we've got 3 telescopes, in fact, in Chile. One is offline at the moment, the ultra-wide field, but we've got Chile 1. Let's have a quick look at that, because that's really well tuned for, look at that.
Oh.
Now, what do you make of that then, Mike? It's not everybody that brings you tri-color Jupiter.
Well, I've seen these things, and I sort of salivate because it's a problem waiting to be solved.
Exactly. Now that is commonly called Slooh art. That is when the real-time processing goes slightly awry, and in this particular example, actually, it's a great example of what we do to create the real-time color images, although this one didn't quite work. But the cameras that we use on Slooh's telescopes are these ultra-sensitive CCD cameras, but they're grayscale. So they only produce a grayscale image. So to get color images, you take images through 3 different color filters, and you guessed it, red, green, and blue. And those are merged together normally and produce a color image. Now, this is probably because this is Jupiter is incredibly low still. So it's probably not getting enough of a signal on the camera to be able to align these properly. So we'll keep a little eye on that. But let's take a look at, so Chile 2, actually, I think we have got Chile 2, Andrew, running tonight, haven't we? On intermittent missions. So Canary 4 is running, yeah. So let's see if, no, so we haven't picked a good spot to do that. Nice galaxies there, though. Let's have a quick look at the queue, see when the next one up. Andrew, maybe you can give me a shout out when Chile 2 is going to, actually the next mission is, so we'll kind of stick around on that.
And by the way, just very quickly, there's some great chat comments showing up in the chat section. So I know we don't have time to go through each one of them, but boy, I'd love to. Okay,
well, you can pick some off now, Mike, if you like.
Oh, no, I'm just like, I mean, hey, there's hello from different people, and someone saying, why is Chile 1 showing a red and blue image? Charleston, West Virginia, Philadelphia, is that Stan? There's Stan, hi Stan. India, Denmark, California desert, Austin, Texas, Montreal, Bangladesh, New Zealand. It's just incredible to have this global community, and we're gathered around the telescopes enjoying this. This is the essence of Slooh to me. It's just this community of interested astronomers, and you know, it's just I just wanted to take a moment and acknowledge everyone who's here. So welcome, glad that you're here, and we're looking forward to a great evening of observing this tonight.
Right, let's go back then, Mike, to our quest, and open this up again. So this is new quest that we've launched tonight. So quests, for anybody who doesn't know, kind of activities that you can do where you learn stuff, but you use the live telescopes. And this is called a moment quest. It's a collection quest, but it's a moment quest. And these are designed around a specific celestial event. And the last one that we did was for the Ring of Fire solar eclipse. But we've got this one as well. There's going to be a second quest that launches tomorrow. But I just want to step through this really quickly, Mike, because we've got some really cool information here. So when people are, after the show tonight, when they're still watching the live feeds and stuff, they can hop through this because, yeah, there's some pretty cool stuff in here. So this is a graphic, actually, that the graphic that you were talking about is from another new quest that we launched about 10 days ago, In the Footsteps of Kepler, Planetary Motions. And it's all about learning about Kepler's 3 laws of planetary motion. What you can see here, I've got a zoomed in version of this. So Mike, what you were saying before, explaining what opposition is. So first of all, can you tell us the difference between a superior planet and an inferior planet? And when we talk about an inferior planet, we're not talking about poor little Pluto that was demoted and is feeling terribly sorry for itself and got an inferiority complex. But what's the difference between an inferior planet and a superior planet?
No, it's a great question. So it's simply that an inferior planet is between us and the sun, and a superior one is beyond us and the sun. And
so we've basically got two inferior planets. We've got Mercury and Venus. And I'm right in saying that those 2 planets can never have an opposition from our perspective, can they?
Well, no. I mean, for that to, as I said, an opposition would have to, it takes place when this Earth, if you can think about it, if you draw a line between the sun and the planet, and the Earth goes between that line. So we, of course, never do that. And so
yeah, so we've got sun in the center of this diagram. Here we've got an inferior planet, could be Venus, could be Mercury. And you can see the Earth can never, ever get between the sun and it. What we do get is we get greatest elongation, and we get to see the phases of inferior planets really, really well. But we also get to see phases of superior planets. So as Mike was saying, superior planets, anything in orbit outside of Earth's orbit. So let's pretend that this is Jupiter down here, and this is exactly where it would be tonight. So we've got the sun over here. Here's the Earth. And directly opposite, 180 degrees as far as celestial longitude is concerned, is Jupiter. And that's why opposition is a particular moment. It doesn't last for an entire night.
No.
Opposition actually occurs in about 7-8 hours. It's at 0746 UTC. So I think that's about 8 hours time. And that's the moment when the Sun and Jupiter are 180 degrees apart from Earth's point of view. And Mike, you were, let's hop back to the quest, because there's some cool little things in here that we should probably
you do have the next Jupiter on Chile 2, by the way.
Do we? Oh, thank you very much.
And there's so many things about the while you're cat. So one way to think about this also is if we were on the planet Jupiter and we were looking at the sun and everything was perfectly lined up, we would actually see the Earth transit the sun, so because the Earth would pass in between the sun and Jupiter. So, but the angles are off, and so I know that's not a thing, but still, that's one way to think of it mentally. But back to the quest.
Exactly. The other thing that I hadn't thought about until I'd done this quest is the moon enters opposition every lunar month. At full moon, the moon is in opposition, and I had never twigged that before. Now you still have the above and below issue, but as far as the celestial longitude is concerned, I'd never really
we have a full Jupiter tonight.
Yeah, exactly. And we're going to talk about that a little bit later, Mike, because it's quite important, and it's highlighted in the quest about this thing that Jupiter and its moons are being illuminated straight on. So when we look at this at the moment, imagine you are the sun, right? And you're looking at it, you're illuminating, you're illuminating Jupiter straight on. You're not illuminating it from one side or from the other side, because Jupiter and Earth relationship is different. And that's why we even see phases in superior planets beyond Earth. And if you go back, you may not have noticed this. Sluvians, we've decided that Slooh members are now called Sluvians, if that's okay. If everybody agrees, put your thumbs up. If not, you can give us a thumbs down. Do you want to be a Sluvian? Yeah, we're getting loads of thumbs up. We are Sluvians from around Earth, joining together around some telescopes. So that's quite cool. Anyway, Sluvians, look back at some of the images that you've captured of Jupiter earlier on in this apparition. Now, an apparition happens for any particular object, but we normally refer to it for planets. Oh, look at that's coming into color. This is a good view. We can just see the great red spot. That's worth a snap, please. That's definitely going in my quest poster. So I've got that one. So I click that, have a closer look at it. That's quite cool. I like that. So have a look back at some of your earlier images in this viewing season, the apparition, which lasts about 9 months or so. And what you'll see is on the right-hand side of Jupiter, you'll see it kind of looks slightly darker than the left-hand side. And there's also some interesting phenomena that we'll talk about a little bit later to do with Jupiter's moons. We can see 2 of them here. If anybody wants to have a look, I have got a program that I can look it up, but if anybody wants to have a look, see what these 2 moons of Jupiter are, these 2 little smudges on either side, we can take a look at that. In fact, let's spark it out. Let's take a look now, shall we, Mike?
I think it's Ganymede. I'm looking at this in Solarium. Ganymede and Europa on the other side, potentially.
Okay.
Io and Ganymede are both on the.
Yeah, we got Io and Europa.
Yeah, there we go.
So there we go. So this is a lovely little bit of software. There's a free version of this as well called JupeSat 95, which even though it says 95, it still runs on Windows 10. But here we've got, so this is all set up to be the exact time. There's a little setting in here that you have to have so that the great red spot shows up accurately, and you can just about see it there. I think there's a zoom control here, zoom in. So the great red spot is just disappearing over here. But what we can't see then in this image is Ganymede, and Ganymede is just around here. What we will see, though, a little bit later, and if I run this clock forward a minute at a time, oh no, it's actually coming out of occultation. So when one of the moons goes behind Jupiter, it's being occulted. But I think by the end of the night, so 3, 4, 5. I
Yep.
think we get an Io transit. Look, great red spot comes back into view. Bang!
Yep. There it
That
goes.
is what we're going to see. Now that
Oh, fantastic.
is almost to the minute. Let's put it on the minute, shall we, of opposition, which is 46.00. So we are going to have, in the morning, Chile's looking great. Clear skies. I've said it now, haven't I? We are going to see, at the moment of opposition in the morning, great red spot, bang, smack, center. And then we're going to see Io. But what members may notice is something quite interesting, and this is something that only happens tonight. When we normally see one of Jupiter's moons transit Jupiter, if it's before opposition, when the sun is over to the left from this viewpoint, we see the shadow of the moon cast on the planet's surface before the actual moon transits the planet. And this is one of the easiest ways of telling whether or not you're viewing Jupiter before or after opposition. Now tonight, remember what I was saying, the sunlight is hitting Jupiter straight on. It's also hitting that moon straight on, which means its shadow is directly behind it. The moon itself is covering the shadow. But tomorrow night and the night after that, what we're going to see is the moon will first transit in front of the planet and the shadow will trail it. And I got a lovely, lovely little drawing of that in the quest.
Beautiful.
So I just always love that little fact. It's so easy to tell, you know, where you are in comparison to.
Well, it's neat because it really just illustrates that geometry of everything, and I think it's such an important insight to talk about, because a lot of times we just look at these images as though they're static 2D things, and they're actually just this representation. So that was a nice.
Mine is unmuted.
So Mike,
Mike showing this guy once doing the Zoom. So they're controlling the whole.
Couldn't work out if Stephen was actually trying to communicate to us then. Mike, what I was going to say was, you went through very briefly what opposition is, and that's really clear. And it's actually, the lovely thing about opposition is it's a really simple, you know, concept to get to grips with. The sun is opposite the planet from Earth's perspective. But there's a whole stack of other things that really matter to us as far as observational astronomy is concerned, and when we're looking at Jupiter. And we've got them in the quest here. It's visible all night long. You showed us that earlier. So as the sun sets, it rises in the east. When the sun rises, the planet sets in the west. Exactly the same as that. Now, the other thing we've got is that it's near to its closest to Earth. And we'll maybe cover that a little bit. But that means that its apparent size is at its biggest for this particular apparition. And it also means it's brightest. Now, that means it's brilliant for catching the detail. Now we're still waiting for it to climb a little bit higher before some of these images get nice and crisp. But the reason, Mike, maybe you can say why, because it is a bit counterintuitive, and we see this more so with Mars than we do with Jupiter. But why isn't Jupiter always closest to Earth at the moment of opposition? You'd think it would be.
Well, it's a great question. I mean, it really has to do with the ellipticity of the orbits. And if things were perfectly circled, then yes, they would line up perfectly as 180 degrees. But because there's a slight ellipticity to the orbit, it doesn't turn out to be quite that way. So it's pretty much that.
So a planet, and especially Mars, has got this highly elliptic orbit. So it can be in opposition to the sun, but actually if it's furthest away from us in that elliptical orbit, and the way the two orbits, Earth's orbit and the elliptical orbit of Mars, come together, you can actually get the planet being closer to Earth in a few days after or a few days before. But anyway, we've already said that it's nearly fully illuminated by the sun, so it doesn't show any phase, similar to the full moon. Another interesting one, which if we won't go into it tonight, Mike, but if any members out there want to learn a little bit more about this, go over to the In the Footsteps of Kepler Planetary Motion quest. And tonight, if we were to look at Jupiter against the fixed background stars, it wouldn't move, would it?
I was totally reading the comments, Paul. I'm so sorry I missed that.
All right. I was talking about at the moment of opposition, we're used to knowing that the planets are the wanderers. That's what the Greeks called the wandering stars. They saw these lights, traveling across the fixed background stars. But tonight, at the moment of opposition, we're not going to see Jupiter move, are we? It's at a standstill.
No, that's right, because, and this actually brings into play this notion of retrograde motion, because what happens is if you sort of think about the sun and the Earth, the sun and Jupiter as being these two points. Oh, there we go. Great. Okay, so here we go. So yeah, if you think of the sun and the Jupiter as being 2 points, and the Earth kind of passes between it, it's almost as though you're looking at Jupiter coming by, and then right when you're passing by, you actually have to turn around and look at it sort of through the rearview mirror in a way.
We're overtaking Jupiter tonight, aren't we?
We are. It is, and
we're in the fast lane.
We're in the fast lane, because you think of planets perhaps as all having the same speed, we're all rotating, and it's not that way at all. And so this is one of those moments where, it's kind of funny, because you can actually see. So in other words, what this would, to Paul's point, what this would mean, practically speaking, is if you're looking at Jupiter against the stars, it would be moving in one direction, but tonight it's going to stop. And then tomorrow night, it's going to start moving in the other direction a little bit. So that's just another way that you can work out the fact that the solar system is a thing and the Earth is not at the center of the solar system. So it's all these beautiful things that just all fit together in this scheme of astronomy.
Exactly. And John's quest, that Kepler quest, the planetary motions quest, really explains all of that so well. And it goes over the history of observation, of how those observations of planets going into retrograde motion, absolutely phased the minds of, so many famous astronomers down the ages. But let's just hop down, because there is a little section in here that one of the other really important things from my point of view as a Jovian lover is on the night of opposition, because the planet rises as sun sets, because it sets when sun rises, we see Jupiter all night long. That's the same for any planet that's in opposition. For deep sky objects, we call it culmination. So midnight culmination is when an object is visible all night long. But from Jupiter's point of view, Jupiter spins. Let's see if we can get a nice, let's see what telescope I'm on. Let's hop over to Chile 1. So I want to point something out to you, because we kind of think of celestial objects as being fairly perfect, don't we? But we still got that one. That's certainly far from perfect. Oh dear, I got into trouble a few years ago, didn't I, about mentioning two suns and the fact that NASA were hiding the second sun from us. Well, that's nothing. They're hiding the blue Jupiter from us. Let's see. Is that the wild duck cluster? Is that Caldwell 94? That is a beautiful star cluster. Look at that. That's live through one of the telescopes. Anyway, look, we can't see it too well here, but hopefully viewers can see, and they can see some from maybe some of the others. So Andrew, give me the nod when we got a Chile 2 or a Canary 2 as well, actually, Jupiter coming in, because we'll see it clearer there. We can see that Jupiter isn't round. Mike, why is my favorite planet squished? Who did it? Because I want to hold them responsible.
Great question. So this phenomenon just permeates so much of astronomy. It's basically the same reason for why the solar system is a disk, why the Milky Way is a disk. Why is the Milky Way the shape of a pizza? Why do all the planets in the solar system all orbit the sun in the same plane? When we see, if you're up tomorrow morning or the next morning and you see all the planets straight out in a line, why are they in a line? Who put them in a line? How do they get into be a line? And it's the same thing with Jupiter's oblate spheroid shape. So what happens is Jupiter's a huge planet, and it's this massive body of gas and liquid gas and all kinds of stuff spinning. And because there's so much mass there, there's a huge amount of gravitational force trying to compress everything together. And this is one of the reasons that the interior of Jupiter is so dense. and the components of Jupiter are these interesting manifestations of matter. But at any rate, what happens is around the equator, the spinning is, there's a certain amount of centripetal force or inward acting force required to keep the equatorial region in a circular orbit. Same reason that the Earth orbits the sun. If we suddenly took out the sun, the Earth wouldn't go in a circle anymore. It would just shoot off in a straight line. So all the stuff at the equatorial region of Jupiter is circular, orbit is rotating around the center of the of Jupiter and the core of Jupiter. And it's that gravitational attraction between the core and the outside stuff, which is keeping it in its circular orbit. Now, at the north and the south poles of Jupiter, however, not so. There, on the other hand, there's no rotation. It's basically, it's like if you think about the North Pole and the South Pole of the Earth or on a globe, there's no really circular motion that is in need of a centripetal force. So gravity tends to just pull that stuff downwards. So it kind of compresses at the top and the bottom of the planet noticeably. Same with Saturn, because the speed is so great. And in other words, if you think about it, if you think about Jupiter just sort of existing in space without spinning, think of it in the reverse way, and then all of a sudden you started to spin it, the center would start to bulge out because of this, this need to balance the orbital velocity. But it's a very common phenomenon. Same thing if you think about the gas cloud that the gas cloud that the solar system formed from. Same thing, the whole thing starts spinning and eventually it just collapses into a disk. Same thing with spiral galaxies. And
so it's spinning so fast that it bulges out at its equator. And you mentioned it. You mentioned my favorite term in the whole of certainly astronomy, probably any technical jargon at all, an oblate spheroid. All right. And it's spinning so fast that it squishes down. But the reason why this is really important to us tonight, observationally, is Jupiter is spinning faster than any other planet in the solar system. It's day. If you were floating above the Great Red Spot at sunrise, you'd see the next sunrise. In other words, the length of your day would be 9 hours and 56 minutes. That's how fast this gargantuan planet is spinning on its axis. And that means that if you can observe it for around 10 hours, you get to see its entire surface.
It's incredible.
Okay, so can we do that tonight?
Can we do that?
Well, we can't from the Canary Islands because it's summer. We've got really short nights there. We've only got about 8 hours, just over 8 hours of missions, which actually does mean, this is an estimate, but it does mean that we will be able to see the entire surface. It just means we won't be able to see all of the surface centrally in the planet as we look at it here. So some of the features that we saw when we first started were right over to the right. Some of the other ones that we'll see in the morning are right over the left, so we will see it. But the lovely thing is, and I worked it out especially for this quest, is that Chile is in winter, long winter nights. We've got 11 hours and 35 minutes of nighttime tonight. So if the clouds stay away, you'll be able to snap images. It looks like the Chile 2 telescope's providing our best images at the moment. You'll be able to snap away. Still really low in Chile as well. Andrew, maybe you could look up, tell us how low Jupiter still is from Chile. It must be starting to rise a little bit by now. But anyway, it does mean that if you carry on snapping images throughout the night, you are going to be able to capture the entire surface of Jupiter. Now, that's going to look pretty good in the poster that I'm about to show you in this quest, but wait until the quest that we'll launch tomorrow, or maybe even Wednesday morning, which is going to allow you to turn all of those Jupiter images into a time-lapse animation. So you'll be able to create a time-lapse animation of Jupiter spinning entirely on its axis. That is going to be so cool. And don't forget what we looked at earlier at the moment of opposition. at 07:46 UTC, which is in about 6 hours time. In fact, I think it's 7 hours time, almost exactly 7 hours time. We're going to see the great red spot there, and we're going to get that little moon Io, and its hidden shadow behind it transiting in front of that. But anyway, let's have a quick skip through here. So we talked about where did the shadows go, and we've got these lovely diagrams. These are so cool. Tells you all about it in there. So this is a quest. Then you've got to test your Jovian knowledge. So we've given you the answer. So anybody who watches a live star party gets, this is why I've been asking Mike some of these questions. Mike didn't know why I'm asking. You probably don't know why I'm asking, but I know why I'm asking. It's because I put the questions in the quest, and now you know the answer.
Very clever, Paul.
So I can see Ellie. I can see Ellie the Great there. See, she's watching, and she's now got the answers to this quest. Hi, Ellie. Nice to see you. Give us a wave. Thank you very much. So look, here's what we were talking about earlier. So we know that from this sketch, and this is from about 1910, something like that. We know what we said earlier, that this sketch was made very, very close to observation because the moon and its shadow are almost aligned. Right? So we know that we're probably within days, I would suggest, of opposition. And there you go. Look, there you can select the right answer. We then got Jovian features. Now, Mike, don't know how clued up you are on Jovian features, but you know, there's let's have a quick look at the images, see what we can pick out. And really our images need to be a little bit clearer than this, which they will get throughout the night. The telescopes will cool down, the winds will drop.
Chile's about 20 degrees.
So that's really muddy, Andrew. Thank you.
And TD is about getting on for 35 degrees, but there's quite a few wind gusts, so I think that's why we're getting some shaky images.
We're getting a bit battered around all over the place tonight. But you know, this is, why do I keep doing the wrong telescope in here? So let me close this window down. So we've got Chile 1. That's one telescope that we've got. That's the one that's not aligning our images. So we've got those lovely color images. This is Chile 2, the 17-inch. Oh, look at that. Right, that's a good one. Right, I'm going to snap this, Mike, because this is what we're going to talk about when it comes
to
Chile 2. Chile 2, yeah. So this is only 20 degrees above the horizon. Now, more than anything, planetary imaging is affected by the object's altitude and sky conditions far more than deep sky images. Deep sky images, we take very, very long exposures of those. So when the atmosphere kind of shakes around a bit, it kind of cancels itself out. But with this, we're taking the shortest possible exposures with the cameras, combining them all together. So if there's a momentary poor bit of seeing or shake of the atmosphere, or wind gusts, as Andrew was saying there, you know, it affects the image badly. But this will do us as far as this conversation is concerned. So I'm going to snap that image. Hopefully that came up. Did it snap? Everybody's snapping so many images. Or maybe it's because I've got, maybe it's
snapped and it worked fine.
So, oh, there we go. Oh, look, and they all came in at once then. Right, so I'm going to open this up in another window, and we're going to have that over there. And we're going to have our quest over here. So, Mike, let's talk a little about Jovian features. So I wonder if I can increase the size of this so everything increases.
Oh, there we go.
There we go.
Yeah.
So right, what are we looking at here? So both of these, actually, one thing to tell you, one thing just to remind you, that sketch on the left is actually inverted. So north is down, south is up, whereas all Slooh images are north, up, and down. So it just changes the names a bit. But what are we looking at? We can see very distinctive light and dark bands.
Yeah, no, this is one of the great things about Jupiter. And then if you're able to observe it yourself through a telescope, or even, I don't know about binoculars, but you'll be able to pick out some of these things. So what's going on here is that Jupiter, like the Earth, has a gaseous atmosphere. So if you think of Mercury, the planet Mercury, right next to the sun, no atmosphere. It's been completely burned off ages ago, just like our, well, anyway, just like our moon. But Venus outwards, we all have these atmospheres. And what distinguishes Jupiter and Saturn and Uranus and Neptune is they have massive atmospheres as compared to Mars and Venus and Earth, because really of how close or far the planets are from the sun. So if we look at the planet Jupiter here, you can see these lines across the planet. And this is just such a fascinating phenomenon that's apparent in Jupiter in particular, because of the special combination of surface temperature. It hasn't completely frozen over, so that it's still gas, mostly hydrogen gas, in fact, but some ammonia, some methane mixed in there, just enough to give it a different colors. And what's happening is these different bands, I don't know how many realize this, but these different bands are actually, some of them are moving in the same direction as Jupiter is rotating, and some of them are moving in the opposite direction of Jupiter's motion. And you might say to yourself, how's that possible? What's causing that to happen? And it's just a really, really fascinating. It was the same thing on Earth, actually. If you look at the movement of the jet stream around the equator, it's from east to west. But from mid latitudes where I am right now, and many of you here is in northern hemisphere and in the southern hemisphere, it's the other way around. It goes from west to east. So, but what happens is, what's really interesting, and what's so fascinating, especially if you get onto some of the high res images, is you can see the interfaces between these different bands. That you have this these interesting phenomena that we'll be talking about. And I'd also like to, it would definitely be worth talking about why these different bands are moving in opposite directions as well. Please, let's talk about the Coriolis force. Because if we can manage to, in one live star party, talk about the Coriolis force and the centrifugal force. These are two sort of fictitious forces in physics that are just always a lot of fun to talk about. But there's some neat physics going on in these different bands. So we have these dark bands, and we have these cloud bands, we have these dark belts. And some of them, as I say, are rotating in the same direction, and some of them are rotating in opposite directions. And it's a very, and the colors come from these organic molecules. So there's some really neat stuff to go to explore, depending on which tangent we want to go down first, which rabbit hole we want to go down first.
So one of the interesting things, and I'll maybe dig out one of my historical images of Jupiter, is that the dark regions that we're seeing, the dark stripes, they're called belts. So it's basically split. Jupiter is split into the equatorial zone in exactly the same way, actually, as the Earth. So in the center, you've got the equatorial zone. Then you've got the tropical zones. Then you've got the temperate zones. Then you've got the polar regions coming out. And these are all separated by the dark belts and the light stripes. Those are zones. So you've got light zones, you've got dark belts. And what's fascinating to watch, even over a single viewing season of Jupiter, let alone when you look at it over years, is they change, and they change so dramatically. Sometimes they disappear altogether. Now, if you look at the illustration on the left, which is, this one is from 1923, that's how they were looking at it back then. But look how little definition. We can see the north equatorial belt, and we can see the southern equatorial belt, the two dark ones. So we've got, let me point it on screen, this one here, we've got this one here. Then we've got the southern tropical zone in there, the very white one. And it's between those two southerly belts and zones, that's where the great red spot resides. And there's some really, really cool stuff in the quest about that. These dark regions here, these are called festoons. And you can always tell a festoon because they're usually diagonal, and they join, they bridge over between a belt to a belt. They usually go over a zone. So those are some of the features. But also, when we start getting, when this rises a little bit later and we get to see it a bit better in the Chile telescopes, we may start to pick out some of the smaller features. There are loads. The Great Red Spot isn't the only storm raging on Jupiter. We've got Great Red Spot Junior, Oval BA it's called, but Great Red Spot Junior is a far, far better name for it, I think. And we've also got lots of white oval storms as well. And in fact, an amateur astronomer discovered one a few weeks ago. He was the first person to report it, and it's now been named after him, which I think is quite
fantastic.
Cool. So anyway, let's just skip through this because I want to get to the poster. So observe your images, great red spot here. Now, listen, what I've got here is some great sketches down the ages, because the great red spot is basically the incredible disappearing spot.
Definitely.
Right? This is what it looked like in one of the first photographs in 1891 of Jupiter.
Wow, that's amazing.
Look how enormous it is.
Yeah.
3 or 4 Earths would fit across the great red spot in 1891.
That's a great perspective.
Shall we take a little bit of a kick forward? And here's a sketch that was done in 1906. And look at the definition that they've got in here. Look, we've got those 2 festoons there, just like we're seeing tonight. But look at the size of the great red spot. We saw it earlier very quickly. We'll see it better later when it rotates into view again. But once again, those smaller white storms, those white ovals that I was talking about, those in this particular sketch are the size of Earth. So you can see how many Earths would fit inside the red spot in 1906. Then we move on, and actually it's changed shape. You can see it's not elongated quite as much, but you can also see that it's between the belt and the zone. That's where it's all happening. You can still see those enormous white oval storms in there as well. So you can see all of this, but there's a little bit in here. Hubble Space Telescope images from 2014 were able to measure the great red spot really accurately, because strangely it's quite difficult to measure the precise size. You know, it's got fuzzy edges and stuff like that, but when you're up close to it or got very good eyesight like the Hubble Space Telescope, you can measure it quite accurately. And there it is, 16,496 kilometers across. I'm surprised they didn't have decimal places on that as well. It's so accurate. 10,250 miles. That is less than half the size it was during these other sketches. And it's been diminishing ever since. And I looked, and there's a little bit here in the quest that you can look at. I looked back at Slooh images from 2012, and I worked out over the course since 2003 and looking at Jupiter images from Slooh that it was reducing by about 480 miles a year at one point.
Oh, wow.
Right back then. I mean, it was really around 2012 was when it was really contracting really quickly. But anyway, so you can see there's some great stuff in there. Oh, look, who's that? I'm not going to give the game away. Nobody give the game away. But there's the question. Who was it that first observed Jupiter's great red spot? Well, there he is, but you've still got to name the person. So anyway, let's hop over to the next step, because I do just want to show you this really, really quickly. Here we go. You're familiar to this. This is our poster. All right. This is so cool. This is the illustration that Andrew put together. We're going to talk about that in a sec, Mike. But you can see here, you can collect 41 images. Collect as many images as you can tonight, because what you can do in this quest is choose your best images to make this high resolution poster at the end of it. And if you haven't done this before, I just want to show you very quickly. So here are all the image slots. So 42 image slots in here. I want to pick number 41 is really important, because if you notice on the poster, there's a big square where it says 41. That is where your favorite Jupiter opposition image is going to go. All right. So I think I'm going to start off with that. It opens up automatically. My Photo Hub, this is where all of your photos are stored. If you haven't done this before, everybody's doing it tonight, so it might be running a little bit slower than normal. But what we've done with this poster is exactly the same as we did with the solar eclipse poster. You can put any of your images in any of those slots. You don't have to fill them all up. You could just put one central one in, but you can organize then, you know, this entire Jovian day of all of your images from left to right or round in a circle or anything else you might like. So here are the snaps that I've taken tonight. Let's take a look. I want a color one for that. I'm going to take that one. So Chile 2. Oh, that new Chile 2 telescope, we installed it when back in January. It's pretty cool, isn't it, Mike? You a fan of Chile 2?
Yeah, I mean, it's just an amazing detail. And the algorithms for doing the post-processing are just terrific, just to bring it all out. So
yeah, and we've still got some work to do on those as well, which would be cool. By the way, we are going to take some questions in about 5 minutes when we just run through this. So if anybody has got any Jovian questions, preferably for Mike, because it's 1 a.m. here. So I'm brain addled because I only finished this quest off about three hours ago, something like that. By the way, the quest normally does select your images quicker than this, but we are stretching my poor little machine, and we're stretching everything else. Ellie the Great looks like she is floating around in space with that backdrop, which is quite cool. So anyway, the image will appear in there. It will do, I assure you, and it will also will it appear? Come on.
I just now figured out how to actually see the different attendees, so it's great to see everybody here, I have to say.
Oh, it is? Oh, you hadn't been seeing everybody, Mike?
No, I was just, yeah.
I'm just going to take, while the quest is doing its stuff, and oh, look, Chile 1's still doing that. So Chile 2, I reckon, is one of our best bets tonight. So there'll be another Chile mission in Chile 2, another Jupiter mission for Chile 2. Yeah, that's coming up in a few minutes' time. What have we got over in the Canary Islands? So Canary Islands is still looking a bit grubby. In the Northern Hemisphere, Jupiter is really badly placed. All the planets are. So when planets are at opposition during your summer, wherever you are, you know it's bad. Because during the summer, the sun's high in the sky, which means at night, all the planets follow the path. They're really low. In the UK here, Jupiter barely gets above the rooftops of the neighboring houses. Down in the Southern Hemisphere, from Chile, it almost goes directly overhead Jupiter. So at, very close to opposition at the end of the night, it will still be really quite high for us. So let's hop back to the quest. Has it loaded yet? No, everybody's doing the quest. Come on, guys, stop doing the quest.
Well, by the way, Paul, let me just briefly interrupt and just and inject a note of optimism.
Help me out here. Yes.
So if you're interested in taking a series of photographs, some of us are with your camera, the fact that these planets are so low to the horizon is actually helpful because they actually fit in the frame of view. So if you have that as something you're interested in, this is one of the better times to do that. So
exactly. So look, I'm not going to go through the other image slots. That will be a lot quicker for everybody. But here you can see that particular image that I've chosen has gone into my central slot. You can do the same in all of the other 40 slots. So what you can do is you can track the entire night of Jupiter's day. I got that right. Let's just take a slightly larger look at this. Because don't forget, all of these are high res and they're made specifically so you can get them printed at your local print firm. But Mike, before we take any questions, let's just talk about this this orrery. All right, so we talked about this just before the show started, but we're looking at a pretty unbalanced solar system at the moment because Andrew configured this orrery and created this this graphic. Timed for tonight.
I know.
So
look at that.
There we can see the sun in the middle. We can see Earth. That's obviously not to scale, but there's something very unbalanced about our solar system, isn't there, at the moment?
Oh yeah, this is just an incredible thing. I mean, every so often, I think it's around every 20 years or so, you can see this. So this is what are we looking at here? Imagine, if you will, that we're in a spaceship. Maybe one of the early Voyager Pioneer missions from NASA back in the 70s and the 80s. And we've actually, just imagine that we're sort of way outside the solar system. And it's pretty self-explanatory. What this shows is a faithful representation of the planet positions at any given time, as Paul said. And so this is dialed in for tonight. So what you can see are, starting with Mercury and Venus, and then we have Earth and our moon. Now, note, I should be very careful to say this is absolutely not to scale.
Yes.
So that's an important disclaimer that that's that. But you can see that Uranus and Neptune are out there. But if you see here, you can see Jupiter at opposition, just like we've been talking about. Look, there's even a line connecting them.
Great line.
And you can see just off to the left, if you will, from Earth perspective is Saturn. If you think back to that all sky image.
Yeah, I was going to go back to that because we may have picked up Mars by now. So
let's see.
Just take a a little look in here. No, not quite risen yet, but we will, I think, start seeing Mars rise up down here.
Pretty soon. Pretty soon. And yeah, and so, I mean, I was just realizing this is, I have a similar thing here. This is just for the, for the Earth and the Moon and Mercury and stuff. But it's a very handy, it's like a mechanical gizmo. It's called an orrery, O-R-R-E-R-Y. And I think I spelled that correctly. And it's just a really neat way to visualize things because you can actually very physically see how the objects are arranged spatially with respect to one another. And you can see how the progression of time, how the planets move. But take a good look at this, because this is the one that Paul's showing us here in this poster that you can all put together for this quest, is really a special one that you won't have a chance to do this again for quite some time. And what's happening is, just as a matter of the way the planets orbit, everything's lined up. And it's just really, really neat to see that. You can see Venus. Like right now, Venus is extremely bright in the morning sky. Mercury is barely visible. Mercury is very tough to see because of its proximity to the sun. You can only see it either right before sunrise or right after sunset. Mars, on the other hand, is almost, it's pretty close to opposition from a practical point of view, because it's very...
It is. I think that's next month, isn't it? And I think Saturn is in a couple of weeks.
Saturn's in a matter of weeks. So yeah, this is
just to let you guys know, Ganymede is just appearing, I think, on Chile 2. It's just popping out.
Oh yeah.
Oh, there we go. Good catch.
Nice one, Andrew. Thank you very much. So there is Ganymede. So we looked at the simulation earlier. So Ganymede has been in what's called occultation. So it's been occulted by Jupiter. Now, this is also at opposition. It's another period of time when something very strange happens, only tonight. Now, tomorrow night, or in 2 nights' time, if Ganymede was in that same position, it wouldn't be occulted, it would be eclipsed, because the sun, from our perspective, is going to start illuminating Jupiter from the right-hand side, which means its shadow is going to be cast to the left, which means that Ganymede would be in Jupiter's shadow. And that's the difference between one of these planets. When it goes behind the planet, it's occulted, or it can disappear and be eclipsed. And it's fabulous watching that in a live view, because the moon, you see it, it's either so let's say it's approaching from the right hand side, and it would just blink off as it enters that mighty gas giant shadow. And exactly the same thing will happen over the coming nights when moons emerge. You won't see them that close to the planet. You'll only see them when they hop out a little bit further along outside of Jupiter's shadow. So sorry, Mike, I digress, but I'm going to snap an image of that. Thank you very much, because I think that that might be my showstopper. That might be my number 41.
That would be a good. Actually, that's a good point. Let me get a quick snap of that one too. Yeah,
excuse us while we act like normal Slooh members for a moment. Get excited about the live feeds.
Yeah, I mean, not to give away any secrets, but there was these moons were just such a big part of the well, yeah, let's go back to the all-sky camera just for a second. Let's go back to the all-sky camera there. So look, if you come back and look at Jupiter. All right, now let's think about this for a minute. So our sun is to our back. We're looking at Jupiter, and just to the left of Jupiter is the planet Saturn. Okay, so just to the left. So now if we go back to the orrery view, that 3-dimensional view, and if you look, imagine that we're on Earth, and we're on the night side of Earth. We're on the shadowed part opposite the sun. We're over there on the dark side. And we're looking at Jupiter, and sure enough, there is Saturn, if you can imagine, would be just off to the left of Jupiter. And then where's Mars? Well, that's just to the left of all of that. So if you think, just remember that the Earth is the one that's rotating here. So as the Earth rotates during the night, guess what's going to come into view? Mars. And that's what we're waiting for. And then early in the morning, guess what's going to come into view? Venus. And then shortly after that, Mercury. So if you can now imagine that the night side of Earth has rotated all the way around. So we're facing basically at Uranus. Then you have Mercury, Uranus, Venus, Neptune, Mars, Jupiter, Saturn, all above the horizon at one time. Yeah. This is a great time to see this. I mean, oh my gosh, this is one of those historical moments. So none of us are getting any sleep right now. And we have a comet too.
Exactly. And especially to have, you know, 3 of the major planets, Mars, Jupiter, and Saturn, reaching opposition within a very short period of time. So they're all basically at their best. But anyway, we look forward to seeing you share your finished posters, because I know everybody was really, really creative with the solar eclipse one. So it's going to be interesting to see what people come up with this. The other thing that will be quite interesting, I think what I'm going to do with mine is I'm interested to actually show the progression of how imaging quality improves over the night when the planet rises higher and higher. You know, so I'm expecting in my poster to see fuzzy, 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 getting clearer, getting clearer, getting clearer, getting clearer. Best, most beautiful image in the middle. And then as the planet starts to set again, starts getting fuzzy because we're looking through more and more atmosphere. But anyway, Mike, we should see if anybody has got any questions, because sorry, Slooh really should refuse to put Mike and I on at the same time, because Mike and I do like having a bit of a chat, as you can tell.
There's another comment I was going to say about that, but I'll just stop.
Anyway, has anybody got any questions for us about Jupiter?
There's a bunch of questions in the chat, Paul. I mean,
oh, shall I actually open them?
Oh no, if you go to the Zoom chat.
Oh, Zoom chat. Oh, I see. Actually, just while I'm here, actually, Stephen Aman runs the Syzygy club
sure. Here we go.
Slooh, and Stephen is always the person to go to for any celestial event. So he always hop over to the Syzygy club, and he always lets you know what's coming up. So Jupiter's more flattening. We're going to be treated to an Io transit tonight at the same time of opposition. Yeah, we saw that. We got that great red spot transiting at the same time. And thank you for the heads up. Ganymede has just popped out. But let's go over to chat. Oh, I'm going to launch a poll, actually. I want to know, actually, we've got 2 polls. I want to know.
Oh, this would be great to get input.
So the question is, have you captured any event of Jupiter's moons? That's transit, shadow transits, eclipses, or occultations. So I am going to launch that. So anybody who's in the webinar will see that. But let's have a look. I need to find chat, which I
have a question.
Yes, go on.
Hey, how you guys doing? Wonderful show tonight.
Hey, Frank.
Hey, how you doing?
Yeah, very well.
The question I have, and this is a few months off of what we're talking about opposition right now, is that Carol recently talked about quadrature as it related to Mars. Yeah. And was a new concept to me. I only thought that the phases we saw on the inferior planets. And now I know that there is quadrature, a slight phase that takes place in the other planets. I assume there's a very, although we can see it in Mars, I assume there's a very tiny quadrature then that would take place with Jupiter, although we'd probably never be able to really see it.
It is very distinctive. It is very distinctive, actually, Frank. It's not a kind of hard shadow. So the edge of Jupiter doesn't go into darkness, but you can definitely see that it darkens. Yeah. So before opposition, we would have seen the right-hand side of Jupiter darken. From now on, as that quadrature changes, we're going to start seeing the left-hand side. Now, if Mike wants to take some other questions, Mike, I'm going to dig out an image that may actually help illustrate that. Yeah. While you pick off any of the other questions.
Well, let me just try to. I'll just start at the top of the chat, because this goes back. There's some great comments and great questions, and we'll just see how we do here. So, greetings from everybody. Greetings. If I miss your question, I scroll down. Just you can just shout out, and I'm just scrolling down. I'm going to make sure I see the questions. Someone's going over to the Cat's Paw Nebula. We have all sorts of people coming in. Why is Chile 1 showing a red and blue image? Well, it's really, as Paul mentioned, it's an error, so it shouldn't. And so the red and the blue image just comes from a misalignment. So sometimes there's a red filter, sometimes there's a blue filter, sometimes there's a green filter, sometimes there's no filter, and they all get mixed together. So that's just an.
Can I say something?
Oh, please, yes.
It's Rich Tyson from Maryland.
Hey, Rich.
Hey,
yeah.
I was looking at those misaligned images. What I find fascinating with them is that you're looking at, it's like you're looking at Jupiter with two different wavelengths of light.
Yeah, you are, literally.
Like on the red, you'll see certain features, and on the blue, you'll see certain other features. And I find that very fascinating.
Oh, absolutely. No, it's fascinating. Yeah. It is fascinating. I'm glad you mentioned that. That's an excellent point. And, you know, it's like the same, if we're outdoors with our red headlights on and we're looking for something that's red, it's going to be basically black. And, you know, it's just, if we look for something that's blue, rather, it's going to be black. It's just, that has to do with the wave. That's exactly how we, that's why we do it. And it's a wonderful filter for picking out. It's like with any type of spectroscopic filter. In fact, there's our narrow pass filter. You can selectively filter a particular wavelength of light that can be very informative. So excellent point. Excellent point.
Mike, let me pick up on this because this does illustrate it, hopefully, Frank.
Oh, there we go, yeah.
So this is a series of images I've taken over an apparition of Jupiter. Let's just take the top line. So 2012, this is when the Great Red Spot was getting smaller. You can see actually in the bottom row, 2013, you can see how much smaller it got. But the central image where Jupiter is big, that is at opposition. We've got the beginning of the season over on the left. And you can see that's when the sunlight from Earth's perspective was illuminating Jupiter from the left. And you can see a very pronounced darkening on the right-hand side of Jupiter. And you can even see it actually on, let's have a look. If we zoom in a little bit.
That's a great poster.
You'll see here, you know, and I used to think that this was just, you know, before I knew what was going on here, I just thought it was, you know, part of the processing or whatever. But have a look at the planet on this side where it's really bright. Have a look on this side and it's dark. But immediately after opposition, we get the left-hand side darkening and the right side being fully illuminated. You know, so that's a great little illustration, you know, of what we've been talking about tonight. So it is like a phase. It's just not as it's as you were suggesting, Frank. It's not a kind of hard shadow that you get, but it's certainly visible, isn't it, in our images?
Yeah. Something else that, you know, is interesting that Richard had brought up a second ago. I just want to shout out to Richard. I see him on the site quite a bit. Is that I just saw recently by using specialty filters that are not the normal ones that we use, that people have begun imaging tails off of planets where gases are leaving the planetary atmosphere, and you end up with a picture of a couple of planets that actually have like a small cometary tail because they're imaging on, I don't know if it was sodium or what they were actually imaging on. So there's a lot of science to be. We spend a lot of time on getting the right filters for the pretty pictures, if you will.
Yeah.
But there's a lot of science to be done in a magnitude of different bandwidths.
Mm-hmm. Exactly. So I'm just having a look here. This is the live view from the Chile 2 wide field telescope. This is my favorite view that we've got tonight. We can see there Ganymede coming out. Let's just take a little look back. Mike, if you want to pick off any questions while I put up this simulation. So this is what's going to happen for the remainder of the night. I'll just pull this up on screen.
Frank, I see your question here. You said that Carol recently introduced you to the concept of quadrature as relates to Mars. So I think we just talked about that. So I'm gonna okay. And
so
then,
go on. This is sorry. This is just the live view here. This is not from Chile. So this is set up at the moment to be the view from Canary Islands, but this is just the simulation. So there's Ganymede, which has just popped out from being occulted by the planet. If we run it forward, you can see this is tonight. 07:46. Keep an eye on that timer there. That is the moment of opposition in a little over 7 hours time, but let's run it forward. So keep an eye on this one. This is our moon of choice tonight. This is Io, closest moon, orbits really quickly. Great red spot comes into view about 6, and there we go. So at the moment, and that's going to be about, that is the end of Chile missions where that happened. But if we just hop back, we can go back to what we're going to see. So that's roughly it. That is going to be the moment of opposition. Now imagine that in our live views, when Jupiter, the telescopes have cooled down, the air's cooled down around the observatory. It's going to be a cracking view, Mike, isn't it?
Absolutely. Yeah. I see that. By the way, I see Richard has his hand up, so we'll come to Richard in just a second. There's a question here that I saw. I think it's from, is it Lucia Morgan? And it's a question about the plane of the Milky Way changing seasonally with relation to us. And does its angle represent its angle of spin to the sun? And so it's a really interesting question. And basically, and I think you ask a follow-up question, Lucia, if you're still here, about the. Then I think I see here that Sean comes back rough. Yeah, so if you think of the Milky Way plane being like where my hand is, the solar system's orientation is about 63 or so degrees, 67 degrees, something like that, with a relationship to it. Now, the interesting thing is, let's imagine that this tilted hand is the solar system, and now I'm going to rotate it like this. So it's a very sort of a three-dimensional thing. But the point is that if you think of the Earth going around the sun within that plane, you can see how different times of the year you'd have different opportunities to see the core of the Milky Way. So that's the general thing. Especially, so I guess an answer to your question is, so there's my point there is that there's no change in the plane of the galactic plane of the Milky Way and the plane of the solar system. That's a fixed thing that doesn't change. But as the Earth, wherever you are on Earth, as you rotate through the, your normal, daily rotation, the Milky Way will appear to change rotation simply because you are viewing it from a slightly different angle as the Earth, kind of rotates. And that doesn't really change day or night. What does change is where your ability to see different portions of the Milky Way, depending on what month of the year it is. And then you have a follow-up question, Lucia, about why is the plane different than the plane of the Milky Way? Great question. It's just, there's no cause for that. It's just statistically how that happened. I mean, if you think about these clouds of gases collapsing to form the solar system, the overall Milky Way, the different other star regions within the Milky Way, there's a lot of very local effects that have nothing to do with the global effects of the Milky Way galaxy. So whatever was happening within the cloud of dust that gave rise to the solar system, the axis of rotation of that cloud of gas is not necessarily related to the axis of rotation of the Milky Way galaxy as a whole. So that was I guess that's my best effort to answer that one.
By the way, anybody who is watching on the show page rather than being part of the webinar tonight, just to let you know, we're not going to stop artificially early because we've still got some great stuff to talk about. Yeah. But if the show stops on that page, just do a refresh for it, because I have just extended the duration of the show for that. So just check that out if you want. I got a result of the poll. Jupiter moon phenomena. Have you captured any events of Jupiter's moons, transits, shadow transits, eclipses, occultations, etc.? 78% of people in the webinar voted, and 39% of you have not ever captured one of those events. Well, you kind of captured one tonight, hopefully, because you saw Ganymede pop out from occultation. But of course, you can't really capture the occultation because the moon's hidden. But what we've just looked at there is tonight is a great opportunity to capture that Io transit. As that little moon that's over on the left at the moment in the live view, that's going to be coming over closer and closer towards the planet. and it's going to cross over in front of the planet tonight. So some of you don't know whether or not you have or not. There's every few years, you know, there's I'm just going to share the results with everybody there. Every few years, there's something that happens where you land up getting mutual events, mutual Jovian events. And this is where you can see there that Ganymede is lower down than Io up. That has to do with Jupiter's tilt in relation to the solar system and us. When all of those moons line up to us, we can see them actually cross and transit and eclipse each other. And those are mutual Jovian events, and they're spectacular to watch because the celestial mechanics that are going on for all of these little things to line up. It always blows my mind a bit. Somebody was asking there in chat if why not Chile 3 tonight. Chile 3 is online. Chile 3 is not the best telescope to use for planets, but what it is good at is our new mission type. Our new mission object, which is specifically to capture the Jovian moons. Now, I don't know if anybody's actually got these set up tonight. Let's take a little look. I'm just going to close down a couple of windows. Everybody's working hard, clicking loads of images tonight. Well done, but it does slow the old site down a little bit. So let's take a quick look at that. Actually, I wonder if I've got one before. Mike, answer some more questions, and I'll get an example of these particular little missions, because they are quite cool, I think.
They are, and this, so Lisa has a question. Where is the link to the new quest?
Right, so you go. Let me. Sorry, I've got two screens. So I
don't know if you're trying. That interrupts exactly what you're doing. We
find my cursor. Oh, there it is. Right, so up here. So if you're anywhere on the site, let's just go to the dashboard. So you use a little hamburger menu up here, and you go down to quests, and there they are all listed. This is looking pretty healthy at the moment. Look, we've got 3 pages of quests now. It's on the second page, this one, and there it is, opposition of Jupiter, bottom right. There's the other new one up here, summer, winter, celestial gems. That's pretty cool. I wish I could share my post because I'm very proud of it, but I don't want to give the game away. But, anyway, back over to you, Mike.
So that was a good one. And then Roxanne asks, how often does opposition occur with Jupiter? Great question. And it's on the order of 13 months. And this is one of the interesting things about Jupiter as a planet, because if you think about it, if the year has 12 months, so that means that Jupiter spends around a month in each of its sort of host constellations. So I'm going to leave it at that for that one. But great question. How do you give a thumbs up? I want to be a Sluvian, so there's got to be a way to do that. And I'll copy and paste this. There we go, from Lillian. Thank you for that. Thumbs up from Keith. Let's come down. This is one that made me laugh. Keith says, so if you're I'm not that familiar with Doctor Who, I have to admit, but if you're I just thought that photo. Look at that view of the moons. My goodness. Okay, if you're a Galilean Slooh member, then you're a Sluvian Whovian.
Excellent.
Yeah, we were talking about. We're actually Jovian Sluvians. No, Jovian. We're not.
Jovial Jovian Sluvians tonight.
Yeah.
Yeah. So here it is. I picked this up from earlier on this evening. This is 2340. So this is from Canary 3, a special mission that we've set up, new object actually that we've added to the Slooh 1000. This telescope has got such a wide field of view, and it's so sensitive that you can see even on the shortest possible exposure here, the planet itself, the really bright thing, is totally saturated. But what we can see in this view is Galileo's string of pearls, because that's what he called them. So Galileo saw a view very, very similar to this through his tiny telescope. He saw these background stars. So these little white dots up here, the red one here, those are background stars. He saw Jupiter moving, wandering against the background stars. But amazingly, imagine this, all right? Back then, they thought that everything orbited Earth, including the sun. Suddenly, he's looking at this and he noticed from night to night that moving with Jupiter against the background stars were 3 other little stars in a view very, very similar to this. What he then noticed on subsequent nights was that those stars were not only moving with Jupiter, but they were also moving in relation to Jupiter. So this one would move over here, these ones would move over here. And then one night, a 4th star in his string of pearls appeared. And it wasn't very long. It didn't take him very long, because he was a clever chap, apparently. I don't know, Mike, if you knew that, but Galileo apparently was quite a clever chap. It didn't take him long to work out that those 4 little stars were orbiting Jupiter. And that was so impactful back then, because suddenly something else other than Earth was the center of something. So, and this is what I love about Jupiter. To me, Jupiter's its own little solar system in its own right. There's always something going on from minute to minute. We've seen tonight, when we started off, the Great Red Spot. An hour and a half ago, we saw the Great Red Spot. The Great Red Spot's now gone. It's around the back of the planet, but it's going to be coming back. We saw Ganymede suddenly pop out from behind the planet. We're going to see, in a few hours' time, Io and its shadow transiting across the face of the planet. There's always something to see. And not only that, but you saw that other image that I shared of Jupiter over an apparition over a year, over a viewing season. And it changes over that entire apparition, from being small and fuzzy when it's low and distant to growing bigger and bigger. But also those features change. They come and go one night to another, let alone year to year. You start comparing your Jupiter images year to year, and you see just how much Jupiter's atmosphere, how dynamic that planet is. That's why I love it so much. You know, all of the others, do you really see much change? Well, Mars, you see some change, because you sometimes see the shadowy areas and stuff like that, but then it basically just turns into a red mush for 6 months, because you've got a global dust storm that shrouds absolutely everything from view. Jupiter, we don't see Jupiter's features changing, but what we do see year on year is the tilt. And we shared this, I think, in a previous star party. You see the rings tilt, and when they edge onto us, they all but disappear. Venus, we see these great changes. So we've got special missions, don't forget, at the moment for Venus every morning, and we do see quite a big change in its size and its phase. And it looks just like a crescent moon. But Uranus and Neptune, we see their moons moving around them, but we don't see any surface detail in those. So Jupiter, to me, is definitely the king of the planets. Mike, got any other questions? I don't know if Russ was still around to join us. I did see him kind of answer a question in chat, but I don't know if his bandwidth is going to be good enough to talk to us. But has anybody else got any questions that they want to come on air and unmute themselves?
Oh, I think Richard definitely had his hand up for that.
Oh, go, Richard, go.
You'll have to unmute, Richard. We can't hear you.
Oh, look at that.
And we have a couple more in chat. Richard.
Yeah. Can't hear you.
Yes.
I'm still trying to learn how to use Zoom, so I didn't know how to lower my hand.
Oh, right. So it was up, but you didn't want it to be up.
Yeah, I didn't, not really.
Oh,
okay.
That's
cool.
Back in class, we'd say, anyway, it's a thing. Okay, well, you're off the hook. Unless you have something you'd like to. Okay. There is a question about so Lucia has a question. If we take pictures, can we do the poster anytime, or do we have to do it tonight?
No, just the important thing is gather up your images tonight. You can do the quest whenever you want. That quest will remain active forever. Now, just beware, and we put an extra step in at the end of quest, because don't forget, if you claim your badge, you can no longer make any changes to the images you select. But if you go over, let's just, I do want to just show people this, because let's hop back to the quest. So you know that I've already put in one particular image. So collect your images in here. If I've got a better image for that slot, I can just click the edit image at any time. As long as I haven't claimed my badge, I can go back to this, all right? And I can select another image. So let's hop back here a bit, speed it up a bit now. Let's take one of these. So that will then be in that particular slot. So yes, you can change your images and you can do this whenever you like. So it hasn't got to be tonight, but all of these images that you're capturing tonight, so if I hop over now to my quest, you'll see that that image has now taken up that middle slot. All of these images that you capture tonight will also be able to be used in the animation quest. So if you remember, if you've done the in the footsteps of Clyde Tombaugh, where you're reproducing the discovery of Pluto, where you align your images, you can do exactly the same thing with your Jupiter planet images. You're going to use that module. So this is a second quest that will launch tomorrow, but probably Wednesday morning by the time I finish it off. You'll be able to use that tool, bring all your images into it, align them, then turn them into a time-lapse animation, and you'll see. I love time-lapse animations of Jupiter. They are my favorite thing ever in astronomy, just to see that planet spinning around. And now with this new tool, you guys can do it really easily. Daz, you got a question. Daryl from the UK. Hi.
Hi, Paul. Can you hear me?
Yes, we can. Yeah.
Yes.
Great. Lovely to see you. Enjoying the show immensely as usual. It's not a question. I just wanted to point out that Mars is in the all sky camera now.
Oh, okay. Nice one. Nice one. Right. Okay. Fingers and thumbs. Oh, there it is. Nice one. Okay. So listen, let's take a look at this in relationship to, if we hop over to my poster again. So this is what Mike was telling us about earlier. So this little orrery with about 10 R's in it. Oh, that's going to be better. This is set for tonight. So here is the relationship of all the planets in the solar system in relation to the sun. So there's the sun, there's the Earth, there's Jupiter opposition forming that nice syzygy. Syzygy is three objects being in a straight line. Got Saturn. It is. Saturn just off to the left, to the east, and there's Mars. So this is actually around now, because if you can imagine, the Canary Islands is halfway through the night now. So it is literally on the other side of the Earth from the sun. And what we're seeing over on the left is the eastern horizon in the Canary Islands, and Mars is rising above it there. So what a lovely way to join those two things together. Thank you very much, Daz, for pointing that out.
Yeah, that's excellent. Yeah.
So,
and let's leave it on the all sky there for just a sec, because the nice thing about all of this is, and this goes back to a point that we were talking about a moment ago with the quality being changing throughout the night. If you look at the planet Mars there, it's close to the horizon. And just like the sun, as the sun sets or rises, you can, it's actually, you know, much dimmer because it's going through all the layers of the Earth's atmosphere. And this is exactly what Paul was talking about, is if we were to look at Mars through a telescope right now, it would be very hard to get a good image quality because it's so fuzzy. We have to look, but when it comes more overhead, then it becomes more visible and or more, there's less atmosphere it has to travel through, so the image quality improves. So that's a great illustration of that.
Exactly. And the planets are following that imaginary great circle in the sky called the ecliptic. It's the apparent path that the sun takes through our sky. So during the summer months, we know that the sun is high, which means that at night, because of Earth's tilt, it means the ecliptic is very low to the horizon. So draw a curved line from Mars through Saturn, through Jupiter, and you can see how low to the horizon that is. But it's winter time in Chile. So let's take a look at the Chile all-sky camera, and we will hopefully see, hopefully it's running. Yes, it is. Right. This is a perfect example of this. So over here, we can see Jupiter is the white dot here. We can see the Milky Way. So we can still see that same relationship. Look at how high this lovely constellation of Scorpius is here. So we can see the Milky Way coming through, but here we can see Jupiter and Saturn have just risen above the Andes Mountains. They're snow topped at the moment because we had loads of storms down that kept us closed for about a week, I think. But you can see that their trajectory, join the lineup for the ecliptic for those two planets, and it's going to head almost directly overhead. Those planets, Jupiter tonight is going to be roughly where my cursor is now, right? Directly overhead. We could not look through less atmosphere unless we went into space, right? And that's what's so important for planetary imaging. And that's why us poor Jovian fans in the Northern Hemisphere are kind of in the doldrums over the last couple of years, and will be for another year, because Jupiter and Saturn are still going to remain quite low because they're going to be visible during our summer. So when planets are visible to you during the summer, they're going to be low on your horizon. So anyway, that's a nice little thing. Oh, we've got a couple of questions there that I looked at. Where are the other moons? Roxanne asks. Well, one of them was caught up in the glare that we saw there. So if we hop back to a live view, what have we got here? Oh no, we haven't got another one of those till the next mission in a couple of minutes time. So that's Chile 2. Chile 2 is giving us our best.
That's beautiful. Look at that.
Our best views tonight. That's a lovely open cluster of stars there. It's looking pretty cool. So the other ones are outside of the field of view. So when you look at the Chile 2 view, Roxanne, the other moons are even further out, you know, so from that little simulation that you saw earlier, outside of the field of view. But in the ultra wide field views that we get, you will see all four. If you see only 3 or less, then it means that one of them is either transiting, is being occulted, going behind Jupiter, or is just caught up in that little bit of glare. In other words, it's so close. So in fact, we couldn't see Ganymede there because it was so close to the planet. It was caught up in the glare. Lillian is saying, when does this end? That wasn't a cry for help, because she finishes off by saying, because I don't want to leave. Neither do we, Lillian. I mean, I'm not going anywhere. We're still having some fun. So if people want to stick around, I mean, Melanie's cat has even started joining in the fun. I'm not sure see if Melanie's listening when I mention her name. She's not listening, see, she's talking to somebody, and her cat has got into the interview. No, Melanie is now looking at it. So the cat is come into view. Cats are always welcome on a Slooh Star Party. So, hey, Melanie, where are you from, Melanie? Where are you watching from? Well, where is your cat watching from?
We're watching from Canada. We're in Ontario.
Oh, so you're in the same bad state that we are. Jupiter's really low on the horizon and stuff like that. But have you managed to catch sight of Mike's quarry at the moment, which is Comet Neowise? Have you managed to see that?
Oh, no, I haven't. I've seen photos that people have taken in the morning, but I haven't got up early enough to see it.
Well, keep your eyes open for that, because it really is a sight not to be missed. It's very rare, isn't it, Mike, that we get a comet.
It's now becoming visible in the night sky. So you just have to wait till it gets reasonably dark and just look off to the northwest. And it might be, you really need a dark location to really see it, and binoculars helps.
Yeah.
But it really, you know, when it's under dark sky, full night conditions, it's enormous. It's probably, you know, by eye, at least 7 or 8 times the width of a full moon. And it's just spectacular. So give it a shot.
That's really incredible. Yeah, I will.
It really, really. I just saw someone else had a dog coming by. I think that was Paul. They shared their dog. There was one question though, Paul. I want to make sure we don't miss this one.
Yes.
This is an important one for this quest, and it was, oh gosh, where did it go? It was basically, oh geez, okay. Do you have to? So Keith is asking, for the poster, do we have to use the pictures from tonight, or can we use others?
No, you can use others, but of course, you know, the poster is opposition of Jupiter 2020. So So, that's what its purpose is there for, but you could use it. What happens is when you go to one of those data slots, all it does is it takes you to My Pictures, My Photo Hub, and it shows you all of your Jupiter images, and you can select any of them. So.
And then Jatin Wahai asks, how deep are the belts in the storms, like the Great Red Spot?
The Great Red Spot is an interesting one. Imagine, when you see a storm cell, and you see this towering cloud going up above the other clouds. You can see them really well when you're flying. And the Great Red Spot is actually very similar to that. It goes up above the surrounding Jovian clouds by 8 kilometers. I mean, it's this huge tower of red stuff. I always think it looks more orange than red. Since I've been observing Jupiter, it's certainly more orange than red. But it goes up 8 kilometers above the surrounding cloud tops. Now, the smaller oval storms, so the white spots that we get, those are actually colder, and they sit below the surrounding. So they're like a dent punched in the Jovian atmosphere, and I think they sit about 4 kilometers, I think it is by memory, below the surface. But just imagine the Great Red Spot is like this storm cell coming up, this anticyclone coming up from above the outside. So that's the other thing I love about Jupiter. It's those kind of things. It's knowing that when you look at the images, you look at the Great Red Spot, and you know that that's what's happening.
And then Lucia has a technical question. If a person were to double take a shot, how do you cancel it?
You can delete images. So if you're in, let's hop over to My Photo Hub while we're waiting for the next Jovian image. So My Photo Hub. You saw earlier, I landed up taking a few duplicate snaps. So taking time to load, not sure if it's whether or not it's Andrew, maybe Andrew can tell us something while we wait for this. There seemed to be a bit of a gap in Chile 2's operation. I see.
Yes, Paul, that is correct. That's being worked on.
Okay. So anyway, look, here we are in my Photo Hub. Here we can see there's an odd image here of Jupiter, not of Jupiter, from Canary 4. If I go in there, I can just say,
very nice
image.
Very nice.
All right. The other one that actually is, I think, one of the best kept secrets of My Photo Hub is galleries. Now, if you've got thousands of images like me and so many other members, then galleries is a great way of organizing them. And in fact, there was a great observation shared. Who was I think it was Don was asking, how do I identify the Jovian moon? So here we can see this this nice little image here that I snapped earlier of the Jovian moons, and he was asking a question in one of the clubs, how do I identify the moons? I steered him in the right direction where he could do that, and he shared this observation, and he said, I know this is something that a lot of members have done a lot, but this is the first time that I've ever done it. And I love that excitement. And I suggested to him, add it to a gallery, make a gallery of these are my first shots. These are the special shots. This is the first capture that I ever made of Jupiter or Saturn or of the Whirlpool Galaxy or anything like that. So you can add all of these to galleries. You can see I've got a few in here already. And you can just add any image to any gallery. So sorry, Mike, digressed.
Oh yeah, no, this this is all good stuff. So Heidi asks, I still puzzle over Jupiter's core. What's it made of? Why it be so much hotter than Earth's? Is that because of all the hydrogen? About 20 years ago, there was proof presented there's some sort of core.
So Mike, that's one for you. You're a doctor. So that's a doctor question, but it's all got to do with metallic hydrogen.
Yeah. So what is metallic?
Where it's compressed so much.
Yeah. No. I think we can all join in on this one. But so if you think about, where did Jupiter originate in the first place? It formed out of the solar system. And, that means it formed from the same basic cloud of dust or gas, really, that the Earth formed, and the other planets. I mean, it's all the same sort of stuff. And so if you take the, just the sort of the average composition, if you will, then the supposition is there's basically the very, very core of Jupiter is thought to be iron and rock. I mean, just compressed immensely. That's surrounded, I mean, most of Jupiter is like, as I say, something like 90% hydrogen, about maybe 10% helium. And what happens is because there's just so much of it, it's all, think about like a star. I mean, how does a star form? And the recent Slooh quest on the life and death of stars is a great, leads you through this. But the gravity from the hydrogen cloud just compresses so much that you can actually ignite nuclear fusion. I won't go into that now, but that's what happens. Jupiter is not quite that dense, so it doesn't ignite nuclear fusion. It's a planet. But what does happen is the gas of hydrogen actually becomes forced into a liquid, because it's like when if you compress water vapor, it turns into liquid water. But then, excuse me, if you compress the liquid further, it forms a phase that's just denoted metallic hydrogen. And the reason for that is not because it's like a shiny piece of steel that's a metal that you would actually bend and form, but the hydrogen atoms and molecules are just pressed so close together that there's not a lot of nuclear motion, but the electrons are free to roam around. So the electrons can carry electricity, and importantly, generate a magnetic field because of their motion. Anytime you have a moving electric charge, you're going to have a magnetic field. And this magnetic field of Jupiter, which is this, magnetic fields, I think, are one of the unappreciated components of the universe. I mean, there's just so much going on with magnetism, but leaving that aside, why is it so much hotter than the Earth? And that simply answer is that there's two sources of heat. Leftover heat from the formation of the planet in the first place, when kinetic energy got converted into thermal energy through the conservation of energy. There's just things heat up when they form. But then as the planet kind of pushes together, there's a lot of friction that pushes things, it causes heat just internally. There's not a lot of radioactive decay, which leads to the heating in the Earth's core. But it's just that I think it's just the sheer size and mass and volume of Jupiter that causes it to be so much hotter. And
Heidi was asking as well about if Jupiter might have become a star instead, and as massive as Jupiter is, it would have to have a mass of around 10 times greater to become a star,
which really isn't that much greater when you think about it. I mean, that's a lot, but it's not like 1,000,000 times greater or 1,000. I mean, only 10 times away from being a star. I mean, that's knocking on the door.
Ellie the Great has managed to stick with us for nearly 2 hours. Ellie, you're a star. You're a Sluvian star. Well done. So anyway, and I saw Stan's ginger cat there looking rather hungry. So I'm not sure if Stan needs to go and feed the cat. If anybody's got any other questions, otherwise we will, I think, wind up. We've been going for 2 hours. It hasn't felt like 2 hours.
Doesn't feel like it at all.
I mean, I could go all night. Did you know, actually, Mike, I once did a 12-hour solo live broadcast for Slooh. And then we did a month of live astronomy where we did, I think it was 3 hours every night. That was fun as well.
That's a commitment.
I was just saying if anybody here if the numbers was suddenly going to drop off, if they thought we were going to stick around for 12 hours, another 10 hours.
I have a quick question.
We are.
I have a quick question, Mike or Paul.
Yeah, hey, Frank.
There's been stuff that I've read recently about the fact that Jupiter may not have always been in the position that it's in. As we look more and more at the exoplanets that we're starting to find with these Jupiter-sized planets that are in around Mercury and stuff like that, that there's some theories out there now that maybe Jupiter actually was down much closer to the sun at one time, and it has been wandering around the solar system since then.
I haven't read that, and it would surprise me if it had, because the disruption that would have caused to the inner terrestrial planets, Mercury, Venus, Earth, and Mars, would have been catastrophic if it had formed closer to the sun. So these are the exoplanets that they've discovered are called hot Jupiters, and they are Jupiter-sized planets and larger, which are in these very, very close orbits around their stars. What we know of Jupiter is that it clears absolutely everything in its orbit. So if it had wandered, it would be far more likely that smaller planets probably would have been ejected from the solar system. But maybe, Frank, you could share any articles that you've read there. Mike, have you read anything recently about this?
No, I'm with you on this. It's super interesting though, because science is like that. It's an evolving field, and I'd love to see, Frank, if you post a link somewhere, maybe in one of the either in the chat or one of the clubs. That's super interesting, Frank. So thanks definitely for bringing that up.
It would, it is what we've got at the moment with exoplanets is what's called observational bias. So we've discovered more of these hot Jupiters, these large planets close to their stars, because they're the ones that make the stars wobble. They're also the ones that transit the star, which makes it dim, which means they're far easier to discover than smaller Earth-like planets. So we do have this observational bias, but that would be really interesting. Oh, we've got a nice one coming up here. This is the Trifid Nebula. This is one of the seasonal gems in the new season quest. Mike, just before we take any other questions, Todd, would you like to come in, our VP of Engineering? Todd, we've only got a few minutes, but maybe you can tell us, what are the Sluvian development team, as they're now called? We're going to take Lucia's question after this, by the way, because Lucia's got her hand up. But Todd's in the development team, Vice President of Engineering. What are you working on at the moment, which Slooh members might be interested in? This small group, there's only a few thousand of us watching at the moment.
Well, thank you, Paul. Of course, we're always busy, even during a show when, things can come up and need to be looked at. So
how many lines of code have you written during the show?
None, but I've probably queried our database a million times. But yes, you're right. We're always trying to invent new things and new ways to bring content and folks' observations and things to the surface. And I'm excited that we are now working on a new dashboard for members, which is essentially going to be enhanced experiments of the various profile pages, photo hubs, all the community interactions, trying to bring a lot of that to the surface, as well as a new object mapping quest map, which is going to be really handy to be able to find objects in the night sky and what's out there, what's in our viewing area. Won't get too much into that, but we're very excited about being able to bring some of our data to the surface to our members in ways that we have not been able to before.
It's really exciting. I mean, the Slooh map of the universe, where you'll be able to see, all of your Slooh 1000 objects, and it's an absolute treat. And then the quest map, so you're going to be able to follow journeys with all the quests, do one and then naturally go on to the next and the next for their whole development and how you learn all of this stuff. So yeah, thank you, Todd, for doing that. And thank you, Todd and Emmanuel as well, behind the scenes running this tonight. But Lucia, you had your hand up. Is that an intentional hand up? Would you like to talk to Dr. Mike Shaw?
Intentional hand up, yeah, because I didn't want you to go without answering the question.
Carry on, if you can talk up a little bit.
Hydrogen. Oh, when you talk about hydrogen being metallic in the center of Jupiter, is it like a liquid form like mercury? Could it generate an electromagnetic field swirling around? Can you hear me?
Yeah, we can. Lucia, so Mike, I'm not sure if you caught that, but Lucia was asking, is metallic hydrogen, really in liquid form, you know, like mercury, and does that produce that electromagnetic field and the magnetosphere that we know, you know, Jupiter has, which is absolutely vast?
Well, yes. I mean, exactly the right line of reasoning. So, yes, my understanding of the metallic hydrogen would be that it's really more of, so the distinction between a solid and a liquid is, for crystals at least, is does a solid have long range order? In other words, if you think about looking at a crystal lattice, then each of the atoms would occupy a periodic regular spot within that crystal lattice. So I don't know that anyone has done a really good study of the crystal structures of solid hydrogen. But to your point, though, yes, the electrons are mobile, and because of the convection taking place and the rotation, just the movement, everything's very much in flux. Those moving electrons are able to orchestrate and form a very powerful electromagnetic field. And this electromagnetic field is able to produce magnificent phenomena like I don't want to call it the aurora borealis. I guess you would call it the aurora Jupiteralis or something like that. But you're absolutely right. If people were able to ever want to go exploring on Jupiter, they could use a compass with success. So that's exactly it. And Lucia, while we have you here, one of your questions in chat is, if the Milky Way is about 13.5 billion years ago and the solar system is only 4.5 billion years ago, does that mean that the Milky Way was formed from an extremely hot gas nebula? Basically, yes, cloud. And what was going on during the intervening 9 billion years? Great question. Well, all of the solar system history, the planet formation, all of the stuff that's happened. So, and that's what's so interesting about it, is what was happening. What happened after a few billion years? The Earth had to form. You're asking what was in the intervening before the. Okay, so I misunderstood your question. So you have the Milky Way. So I guess you're asking if the Milky Way is 13.5 billion years ago, and the solar system is only 4.5 billion years ago. The Milky Way was formed. Yeah, so that's part's clear. So I guess what's happening is all of the stuff that's going to form into the solar system is coalescing and beginning to nucleate and to come together. So it's a very gradual process, I guess, when you think about it, and it's not something that suddenly happened overnight. So there's a long period of time when all of these different everything had to come together in such a way for things to form. But it's just like stellar evolution. Once things start to kick into high gear, sometimes things can really accelerate and take off. So it's a very non-linear timescale involved with in all facets of astronomy. So I hope I answered your question with that.
Just to say goodbye to Ellie the Great. Thank you for joining us, Ellie the Great. Oh, Pooja, we've got your hand up. You can unmute yourself and come on and ask us a question. While you do that, I would just like to thank Franz, who scheduled this mission to an object called NGC 6559. And I would just like to thank you, because I have never seen this object before, but it looks absolutely fascinating. We've got these dark regions of dark nebula with what look like some reflection nebulae behind. So thank you very much. But anyway, Pooja, welcome to Slooh. Yeah. Where are you calling from?
I'm calling from Minneapolis.
What?
USA, yes. So I'm new to Slooh and still figuring out how to make best use of any missions that I set up. But I do have a general question, and let me relate it to Jupiter in this way. So if the mission is to watch the Galilean moons versus just Jupiter, well, how is the telescope set up differently for these two? Like, who does the setting?
Okay, so what you've got? So here we've got. Actually, let's hop over to the Canary 2 telescope. So you can see here that the Canary 2 telescope has two telescopes. It has what's called a wide field, and it has the ultra wide field. So this is a small telescope that's on top of the large telescope, which has a very wide field of view. So here we can see this is the wide field telescope at the moment. So we get this kind of zoomed in view, which looks a bit muddy at the moment, but then we can hop over to the ultra wide field. Now, those missions for Jupiter's moons only appear in the ultra wide field telescope. So if you set one up, this is the telescope that you would have to go to see it. All right. So when it's operating, that's what you'd have to do. If you use the Canary 3 telescope for those Galilean moons, I would recommend that one because it gives you a color image of it. And in fact, that was at the end of the mission, so we didn't actually see the kind of ultra wide field of that. But, you know, so if you set up a mission for the Galilean moon object, then if it's on Canary 2, make sure you select the ultra wide field telescope, or if it's on Canary 3, you can just go to the Canary 3 telescope, and that's the only view that you'll get. Does that answer the question, Pooja? Hopefully it does. Pooja has muted again. We got some more hands up. Let's crack through a couple of these. I saw more hands than that raised. Lucia's there again. So is Lucia's hand still up, or is that a new hand? Let's hop over to Daz. Go on, Daz, give us a quickie.
It's just a quick one, Paul. When we looked and just had a quick look at Canary 2, I noticed the image had flipped. So the moons had changed sides.
Okay,
and
right.
It also appeared as if the Jupiter had turned upside down from the other images.
And it did. It did.
Yeah.
The solar system has gone absolutely crazy. We brought it to you live tonight. Everything's up in the air. Let's hop over. I just want to show you what's happening. So we're on on Canary. Let's hop over to this view. Look where Jupiter is at the moment. There's an imaginary line that runs from the southern point on the horizon to the north point on the horizon, and that's called the meridian. We now know that this is halfway through the night in Chile because Jupiter and Saturn have just crossed that line. Now, when they cross that line, it's known as being at transit. It's at their highest that they reach during the night. But because of the configuration of the telescopes can't point close to that normally. But what I've done tonight, so that we get a continuous run of missions, even through that transit problem, I've overridden the transit limit. And what happens is the system then sometimes doesn't know which side of the meridian it is, so it doesn't know whether to flip the image upside down or not. And that's all that's happening at the moment. So you know that those missions are within that transit zone, and sometimes they unfortunately flip up the other way. So I hope that answers the question. It's not ideal, but you know, it was better than having an hour-long gap in our missions tonight. Any other hands up?
Well, Paul, we have a couple of, I just want to take a moment, and there's 2 book recommendations.
Oh, we like a book recommendation.
Chat. One of them is for kids. There's a question about, Lisa asked the question, is if you could recommend a book to learn more about Jupiter, what would it be for kids or adults? And for kids, Sean points out Discover Jupiter, and it's the Searchlight Books trademark Discover Planets paperback, August 1st, 2018 by Margaret Goldstein. And then for adults, Sean is pointing out The Giant Planet Jupiter from the Practical Astronomy Handbooks by John H. Rogers. So those are 2, those are in the Zoom chat stream. So those are 2, I hadn't heard of either of those, and we got a couple small kids, so I'm going to check those out. So thanks for those recommendations.
Great, yeah. Oh, there we go, Chile 2 rising. So don't forget, when you're on the live telescope pages, you can always get a live view from the all sky camera down here. We can see the Milky Way arching through. There's our 2 little white dots there. Jupiter and Saturn. There's one of my favorite constellations. I think my 2 favorite constellations are Scorpius and Sagittarius, right next to each other. I just love the shape of them. And
you know, and to me, one of the great things,
Scorpius is enormous as well.
Oh yeah, it is. I mean, one of the great things about those 2 is when you begin to recognize those, they both have very bright stars. You know, Antares and the Teapot in particular. And when you see those coming out of nautical twilight, you know the Milky Way is coming. It's about to show up.
Exactly.
So it's just it's like the opening of the show.
Now, you know, I've got this up on my screen quite large at the moment, but when you look at the images at that kind of normal resolution, a little bit clearer than this. We can see 3 moons now. So we've got one over here. This is Io. We know that's heading in towards the planet. We know this is Ganymede heading back out, or just as I say. And there was one just off to the right as well. So 3 moons. Oh no! I know this is Jupiter opposition show, but Mike, I think we should call it a night. Everybody's done so well to stick around.
Agreed. No, I mean, this has been absolutely just kudos to everybody. I see that Carol is still at 3 a.m. going strong in South Africa. So,
but I've got a big but here. All right, we haven't got our next Jupiter mission for another 10 minutes or so in Chile, and that's giving us the best views. So we won't hang around for that, but we will wait for this mission to go into color. This is one of our celestial gems for the summer, winter celestial gem quest.
Yeah,
this is stunning, and you can tell already that this is going to be a good mission.
This is going to be a good one.
This is the Eagle Nebula. So anybody will remember those pillars of creation that NASA made famous. This object, if you go onto the seasonal celestial gems quest, this is utterly fascinating. It's 4 objects in one. We've got that cluster, that open cluster of young hot stars. We've got the pillars of creation themselves, which is a dark nebula. It's blocking all the sunlight behind. We've got reflection nebula there, which is the light from those bright stars just reflecting off the dust particles in the nebulous cloud. But we've also got emission nebula there, which is all the gas in that nebulous cloud, which is being excited by these high energy particles streaming out from these enormous stars. It is one of the most fascinating and beautiful objects in one, and it always looks stunning, and it always makes my jaw hit the floor when you see the Eagle Nebula go into color. But you can see, I've never noticed that before. Look at that. Can you see this little dark nebula down here? It's like a Bok globule. I don't think they are Bok globules that large, but that those are kind of, they might be. What do you think? What do you think? Do you think it is, Mike?
I mean, when we get the full definition, it'll be easier to tell, but it looks quite dense.
I've never noticed that one before. So that's one of the questions actually in the quest, and it's what is created in Bok globules, and the first option is box.
Well, this is the great thing about anytime you get a new higher resolution, it's like getting a new phone. I mean, you get this new telescope that we all now get to enjoy. Is you get to see more things. I mean, there's some great comparisons of Pluto from 1990.
Here it goes.
Oh, I think look at this, people.
Oh, that is stunning.
That's beautiful.
So this is a live telescope stream coming in from the Chile 2 17-inch telescope down at our observatory in Chile. The university guys who manage the observatory there have done such a sterling job. The country is in such a severe state with C-19. They've been in continuous lockdown. They've had to get special permissions to go up. We've had winter storms there with all the snow. We've lost power multiple times each week, and they've gone up there time after time to keep everything running, and this makes it worthwhile. Look at that.
Sure.
I know this is Jupiter opposition 2020, but we've still got the rest of the night to look at that.
Yeah, we do.
Just soak this one in. This
that's amazing.
Lovely Eagle Nebula, one of my favorites. So I need to take a quick snap of that one. Thank you very much.
That's a keeper.
Mike, got any closing thoughts for us tonight?
No, just it's been a great night. I really appreciate each one of you for joining us this evening and for participating so enthusiastically with your questions and comments. I think what makes it, for so much more enjoyable for Paul and myself and Todd and everybody, for each one of us, is the interaction. Because, honestly, this is something that we could all see in our own way, but it's this back and forth, and especially the global community. I just really enjoy that. And I just want to say thank you to all of you who this is the middle of the night or the end of the day or the morning or whatever it is, it's a great thing. And I hope to see you again sometime. We do have this weekly star party night with the Nightscapes Club. If you're interested in more of this type of stuff, please consider joining us. We're looking at rescheduling it to a somewhat more user-friendly time. Just enjoy the night sky. There's so much to see right now. We have this comet, the planets, the opposition, Saturn's going into opposition coming up. There's always something to see. And it's really been a great time. So thanks so much for having me, as always, Paul.
Mike, one last little thing, because you just mentioned Saturn opposition coming up, and you mentioned something the other day. You asked me whether there was a specific phenomena at Saturn opposition visible through Slooh's telescopes, and it is, and it has to do with that direct sunlight. Can you remember what it was?
I don't. My memory right now with my sleep is roughly around 30 seconds, so you'll have to refresh me on that one.
If you can imagine what we were seeing tonight with Jupiter, all right, the sun, in fact, Saturn tonight, all right, the rings are tilted towards us. The sunlight from our perspective is coming in from the left. So the light reflected off all of those ice and dust particles in the rings is reflected back towards the sun. Most of it is. At opposition, the sunlight is heading directly towards those dust and ice particles. And you get this effect, and I can't unfortunately remember the name of it now. It does have a specific name. But at the moment of opposition, or the hour around it, those dust and ice particles reflect directly back to Earth, and you get this sudden brightening of the rings. It's only visible on the night of opposition for Saturn. So that is one to watch out for in a couple of weeks' time. So listen, thank you everybody so much. Richard, you got one last little one. Richard's got the last word tonight.
Yeah, I remember a number of years ago. Can you hear me?
Yes, we can, yeah. Oh, no, Richard, you're now...
Undo what you just did.
Yeah. That's it. No, you're not back.
That might have been the last word.
It was the last word. Oh no, Richard, we can't hear you. So come on, let's wrap up for the night. It's late for so many of us here. Thank you everybody so much for joining another Slooh Star Party. Thank you everybody behind the scenes. Andrew Dumbleton's been knocking the telescopes into shape behind the scenes. We've had the views in Chile, I think, are going to get better and better tonight. Disappointing, I think, views in the Canary Islands. If you looked at the images that we were getting last night from Jupiter, especially out of Canary 4, they were so crisp, some wonderful detail. So tonight we've obviously got some very bad seeing there, which is unfortunate, but that tends to happen for special events. But anyway, listen, thank you so much, everybody, for joining us. Thank you, Stan, and the other cats, and any dogs. And I think we should all have to bring our pets to all future Sluvian star parties. So don't forget, that's what you all are now. It's official. We are Sluvians. We need some kind of, I don't know, hand signal of some kind. I think that one's taken, isn't it?
So, right.
Is that one already taken? We need it. Oh, and there's Paul McShane, and he's got, a sweet little Yorkie, looks like, little terrier. Oh, sweet. So I won't show you the big hound that's been making the most appalling smells sitting next to me all evening during the star party. So if you saw my nose kind of wrinkle up at any time, you know exactly what was going on behind the scenes. Anyway, thank you very much, everybody. Oh, and Yari has got a big butch old cat there. Oh, he or she is rather lovely. Let's not show my dog that one. Anyway, listen, come on, let's not. This is turning into a YouTube